So thank you everyone. So good afternoon. Today I will share my experience to learn async programming by turning your Flask app into async using Quart. Okay, first of all, I want to introduce myself once again. So my name is Doni Rubiagatra. You can find me at Rubiagatra. And I'm so honored to be here. And this is my first time at Philippines. And my first impression in the Philippines that we have something in common between Indonesia and the Philippines. The first one is we have same bad traffic. So I arrived on Friday. So I just from the airport to the sky high. I just got stuck like an hour to get up from Sky High. So we have same bad traffic between Indonesia and Philippines. And the second one is we have like some same common word. So it like sayang. So it has the same meaning with Indonesia. So it's sayang, and langit, and kambing sakit, and others. So it is really interesting to learn. We have some culture between Indonesia and Philippines. And for the next, I started learn programming not long ago. So I take deeply learn programming back in 2016. So it is 3 years ago, and because I just a beginner back then, I need some friends to learn Python. So I built the community. It's called surabaya.py. It's a Python user group in Surabaya. So we had several seminars, workshops, and even we held the first ever Python in Indonesia at Surabaya. And also my daily job is as a backend engineer at Kumparan. So I just had 1 year experience as a professional. Also, the Kumparan is one of the largest online media right now in Indonesia, and we have like for the past 2 years, because Kumparan is only 2 years old, we have some of the highest growth of the startup in Indonesia. So, and previously I spoke at four Pycons. The first one I spoke at Python Korea. The second one I spoke at Python Malaysia, and the last one I spoke at Python Indonesia. And this is once again I'm so very thankful for my talk being executed at Pycon APAC 2019. So for the scope for this talk, we have like four questions why we have this talk. The first one is why we use async. The second one, we have like some example how we use async and await using asyncio. I think yesterday we had some really good talk about asyncio by Marty about threads, about asyncio. But in this talk we have some example on the web server side, and the second one I have some example with async web scraping. And the last one, I will introducing Quart for like alternative async for Flask. So I just want to ask, is anybody in here already use Flask? Yeah. Okay, thank you. That Flask is our beloved microframework, right? Yeah. It's very easy. I start web programming by learn Flask, but I just want to ask once again, how many in here already use like async web framework like Synchronous or iOS HTTP? Please raise your hand. No one? Just one on the right there? Two? Okay, it's not so many of you. So I will give some example why we need async for our web servers. So the first question is why we use async. As you can see in this graph, it's a really nice graph. So this is a graph about how many CPU different from time to time. So for the top of the line, on the red one, this is how many transistors we can put in our CPU. So from 1975 until like 2010, we double the number of transistors in our CPU. So if you can, so it's called Moore's law. So Moore's law stated that every 18 months or 2 years, we double the number of our transistors. And as you can see on the green line and blue line, the blue line is a single thread performance, and the blue one is a single thread performance, and the green line is the clock speed. So some people have correlated that if we put the double amount of the transistor, we get more performance. So as you can see, like from 1975, like 1990, until 2005, if we double the transistor, we get more performance. But sadly, it started like in 2008. Even we give more transistor in our CPU, it started going down. We cannot gain more performance by just adding transistor, because if we add more transistor, the transistor becomes smaller. And there's something problem with the thermal, about the temperature of the CPU. And the takeaway for this graph is the black line on the black line on this one. So instead we put more transistor, we can put more cores in our CPU. So right now, like in our laptop, like quad core. So the latest generation of Intel, we had 4 cores, 8 thread, and maybe if you have heard about Ryzen Threadripper, is like 16 cores, 32 threads. So on modern days, if we not using like multi-threaded programming for leverage our code, we cannot like gain some performance if we use only like synchronous execution like we're doing right now at Python, especially if we want to make a web servers. So this is, I gave a big picture why I need async for scalability. So imagine I have 3 requests on the web servers. We have first request, second request, and third request. So imagine the green block in here is the amount of time we need to process the request. This is the second request have the same amount of time, and the third request actually have the least amount of time. But because we run the synchronous execution in our web server, especially in Flask, the first request came, and it will proceed to the same amount of time with the block. But the second request, it just wait. It cannot do anything until the first request is done. And sadly, the third request that just take a little bit amount of time, maybe 1 millisecond or so, it needs to wait like the first request to be done and the second request to be done. So it takes a longer time to process the third request. If we are going deeper, so this is the bigger picture, what happened the first request. So if we have the first request here, it will show to our framework like Flask, Django, or something like that, and we do some processing with the request, and we have some database call. So like, can you imagine if you like a query about 100 of row, it just wait. Like a 5 second and a 10 second, it just only wait for the return of the data. And we cannot do anything, we just simply wait. And if the database call gives some returns, it's back to our code, we changing some stuff of the data, and it will throw our framework to give some response. So for the asynchronous execution, we have the same request. We have the same amount of time for each request to be done, but instead of waiting the first request to be done, we can do something else by by execute the second request. So this is the first request. It will come right here, and when it's wait, it just do the other request, the second request. And if the second request make another database call, it just process it for the next request. And as you can say, the third request is to take a less amount of time. We can finish it right now. And if it finished, it will back to the first request to continue back and forth and back and forth. So this is like the going deeper, the first request came through our frameworks, through our code. But when database, we have some database call, we can just do others, like receive another request. And it's done, it's wait about the other request to be done, and back, and it's back, going back to our code and our framework. So this is some techniques to leverage our performance in Python. There's three part of it. If you want to do more at once, you can use asyncio or threads, like yesterday talks. If you want to do things faster, you can use multiprocessing, C or maybe Python extension. But if you want to use async, but in a simpler API, you can use trio or async. Okay, for the method is like the example of async or using asyncio. But first, we can understanding about the generator. So we have some concept in asyncio. Maybe it's called coroutine that already explained on previous talk on the previous day. So I would say that the coroutine is a restartable function. We can restart the function for doing some computation. So this is, I have some simple Fibonacci sequence in here. We import typing for import list. Is anyone here use optional static typing in Python? Just two, okay. It's really nice though. We can use static typing. It is optional, but we can use optional static typing in Python. We can. Right here we define the Fibonacci sequence. We give some input and it's an integer, and it will return a list of integer. And this is our numbers. We have a list. We have a current and next 0 and 1. While len numbers is less than n, the current will exchange with the next, and the next will change with the current plus the next, and we append the numbers of list with the current number, and we will return the numbers. So because the previous talks using PyCharm, I will use PyCharm for this case. So this is some example. This is some example. Hello. So we have the same code right here. If we just run it, it will return the list of the Fibonacci sequence. But if we want to use this function right here, we can just like give receive some result, like how many Fibonacci sequence you want to, but because Fibonacci sequence is infinite, if you want to like, I want to search the Fibonacci sequence more than 10,000, you cannot do with this function. And the next is we have some simple like function with the generator. It has the same current next, but right now we use while true. We have current and next, and it's the same, but this is a keyword. We use yield in this part. So we get some function in here. We can, because it's generator, we must make some loop to gain some data of the generator, and we can print it. And if n is more than 1000, we could break. So this is the simple generator right here. So base a little bit too small. Python simple generator. So instead we put some input like how many Fibonacci sequence you want. We simply just which number do you want when it's break, and the interesting part in here, we can use like debugger in Python to inspect how the process in it. I'll give just some breakpoint in here. We just run the debugger. Stop and rerun. After we give some result equal to Fibonacci function, we simply not execute the entire of the function. We must like have some loops to receive some of the data. So if we F7, after we arrive at the loop, we directly process the function. In here, we get this one, and next, and the yield keyword, and we will back to the loop, and we print if it's not bigger than 1000. We back to the line 11, but for the next execution, we are not back to like the entire function. We just stop and resume, like continue the function from the yield part. So it's like back and forth, like async, async yield. We can restart the function itself. So I'm gonna stop it. Terminal. Yeah, that's a simple generator function. And for the next one, let's explore asyncio. So I have some example with the synchronous version and asynchronous version. The first one in the synchronous version, I import some libraries. Datetime, panorama. If you want some color, if you print something at Python, we have a main function in here. We have T0 to count the datetime of right now. We have a print panorama, so we will print what? We have two functions. We can generate the data, 20 data, and we use this data structure list to store the data. And after we generate the data, we can process the data, and we can how long it takes by subtract datetime now, subtract by T0, and print how long it takes. For the generated data, we have two input, num and data, and we can iterate it. We can start from 1 until num plus 1. We just process the data by like IDX time EDX. We just append with the data set with the data structure in here. We put item, the data itself, and the date time. We need it for how long it takes to process the data, and then we print it. And to like simulate the database call in our previous example, we just use time.sleep and pick a random from 0 to 1 and process it with 0.5 seconds. This is the function of process data. We have processes, how many processes data. We add, if we have the processed data, we just pop the data, we input the value of the zero index and the time with the first index, and we subtract once again like the time now with the day, the time that it created the data, and just we print it, and once again to simulate the delay, we just use time to sleep. So the example, it will like this. It's a synchronous program, we have the same. So we just play it right here. So if you see some delay, that is the time to sleep. So it's generated 20 data, 11, 12, and so on, until 20. And after we generate the data, we process the data, and in this one we have like how long it takes to from it generated until it processes it. So for 20 data, we have like 30.36 seconds in here. This is the example of the synchronous version. For the next one is producer and consumer app in async version. Right now we import the asyncio. We create the event loop, and then it is the same, but instead we use list in our data structure. We use asyncio.queue, and because we use asyncio, we must create a coroutine. So this is a coroutine to generate the data. We create the task, the first task, and this is the second task. We process the data, and we gather the task, and we run the event loop until complete. So the difference one is we instead only we define def in here, we add async keyword, and then in every like coroutine we found, we just put await in here. So this is async queue. We put await in here, and to simulate the database delay, we use instead of time.sleep, we use await asyncio.sleep. And for the process data, it's the same. But once again, we use async keyword in here. Every async queue method is a coroutine, so we put await in here, like in here. And for the sleep, we use await asyncio.sleep. So remember, for the synchronous version is about 30 seconds. How about the asynchronous program? Right. So as soon as he generates the data, it directly process the data. We just not wait the simulation of the database call. We just do something else if we wait, and it's back and forth. Generated item, process the data, generated item, process the data. So we not wait until the end to generate the data, we can process the data. So it took like 18 seconds. So it's really good number for the difference between asynchronous version and the synchronous version of the program. And now web scraping, synchronous version. We have request in here, beautiful soup. Once again, Colorama. We have main function. We want to take a title in a HTML file. This function will get a get title range. We loop from 150 and 155. I'll explain why we use this range. And to get HTML file, we use function this get HTML. This is for the get title. And is anyone in here love to listen to podcast? This is a really good podcast about Python. You should check it. You should listen from talkpython.fm. So I will return music and strip if there's some left blank space in the title. So on this example, we use like synchronous program. Just run the program. So yeah, it just wait. The request for come because we exactly request the the page of the HTML, and after we wait, we process the data to get the title from the HTML. For the asynchronous version, once again we use asyncio in here. We create an event loop, run until complete, and we use once again async keyword in here. We create some tasks. We put some coroutine in it, HTML. And for each task, we can await. And for get title, because we use a beautiful soup, we cannot use await in here. So this is the example. So this is the example how we get the data using AO HTTP. So this is how we request asynchronously in Python using AO HTTP. We create context with client session as session. We get the get URL in its response and response status. Because the method of the text is coroutine, we must await. And the get title is simply the same with the previous one. So I think just like that, and it's done. It's gain more speed. So just quickly, instead of waiting the request came, we just send more requests, and then after we send full of requests, we get the data, we process the data. So it's really nice to have some asynchronous requests in Python. And then introducing Quart for asynchronous Flask. So I want to, this is a Flask documentation. So in this stated that, however, Flask is just not designed for large application or asynchronous servers. Flask want to make it quick and easy to write a traditional web application. So we simply cannot use asyncio in Flask yet. I don't know how about in the future, but we can use something it called Quart. So in this GitLab, Quart is a Python ASGI web microframework. It is intended to provide the easiest way to asyncio functionality in a web context, especially with existing Flask apps. This is possible as the Quart API is a superset of the Flask API. So it means that if we learn Flask for the first time, we write this, right? We just import Flask, we create the root, we define the hello and return the hello string, and we run the app. If you're using Quart, just change the Flask thing by Quart. Simply as that. And you can change the function of dev by adding async keyword in the application. So let's try. So I have some Flask, more complicated Flask app in here. So if we run it, it will take zip code and a country code for when the sunset and the sunrise happen in a day. So this API only works for US and UK country. So if this is a sun service, sun in here. So we give some zip codes and country, and we get the latitude and longitude, and we send the latitude longitude to sun surface to give something like how long it takes to sunrise and sunset. So API sun. So I give some zip code at US. Actually, it's from Cleveland, Ohio, because next Pycon US will have at Cleveland, Ohio. So the return, it will like when sunrise is 6:04 AM and the sunset will happen at 8:28 PM. As you can see, this is like a normal Flask app. If you want to change to async Flask, like async, as I told you, you just like find and replace. So we use in here. So we find Flask. We just replace it with Quart. So it's too big. We just replace Flask and Quart in here. We replace all. Yes. And then we just replace the Flask class in here using Quarts. We replace all and just write just like that. You just run the Python app and you just have some. You just migrate from your Flask app into Quart, and you just click in here, and it is just like that. You just replace the Flask app using Quart. But you must not stop here. You must like implement the async keyword in the Quart apps. So after you create this one, maybe you will add like async. Wait a minute. Like async keyword in Word. Like this, we just add more async keyword in here. We get some requests from the site using HTTP, and then that's it. How we transfer our Flask app into async backward. And then okay, thank you for the create.
Thank you. Now I'll ask the audience if you have any questions. Yes, we have one.
Thank you for that presentation. It's made me quite realize how easy it is to use Quartz in the Flask application. For me, it gives me an impression that Quartz is just the ASIC version of Flask.
Yeah.
So there are things that I would like to ask about if Quartz supports it. For example, for the authentication, yeah, that's like for example in Flask you have HTTP basic auth object defined. And is it also readily available in Quartz?
Because it's still in development, not many libraries support Quart, but you can use Flask library into Quart, but it not runs asynchronously, just like a normal Flask application.
Okay, so it's still on,
yeah,
on the process.
Still have like compatibility with the Flask app.
Yeah, so it's quite promising, but as of now, I think it's good for experimenting.
Yeah, for experiment.
Yeah, thank you very much.
Thank you. Other questions? Going once? Okay. I think there are no questions anymore. Yeah? Oh no, okay. So a big hand to our speaker. Thank you very much for sharing.